Hello, everyone. Welcome to episode number 30 of the Amiga 68,000 assembly programming course. As I was saying, this is episode number 30 of the Amiga Assembly 68,000 programming course based on the book of Fabio Ciucci. And I need to thank Fabio for letting me stream his book. It's an honor for me to do this. Just to remind you, I'm going to show you what we did last time. I believe it was this one. Yeah. This is the last thing we did. This is a scroll text, not using Blitter, but it's using CPU to do it. Okay. We will continue from here, okay, from where we left, and I'm going to jump on the book, to the book. So here is the book, and what you are seeing is this scroll text 8x8 lesson 8H2. Okay, so that's the last thing that we did. We are going to discuss how equalizers, the bars of the equalizers are done when music is playing on the Amiga. Okay, now remember, we already used the play routine. Okay, we used the play routine to play some music in chapter 6, and we said that it has 3 routines in it: the init, the play, and the end. Okay, empty init, empty play, and empty end. Okay, which I will show you again. But this routine has been updated. Okay, so don't compare this routine to what we did in chapter 6, because it is there were some updates. It's still, it still plays mod files, but it's different. It's an updated version. It's not me that updated it, it's Fabio that updated it, and this is from the time that he published chapter 6 to chapter 8. Okay, and remember, the book is divided, let's say, into halves, at least for this book. We can say in three sections, but I'm saying 2 sections for now. The first part, till chapter 7, is for the beginners. Okay, so it's quite easy to follow. From chapter 8 onwards, the advanced part starts. It's also easy to follow, don't get me wrong, but you need more. You need to pay more attention, basically. As you can see, also the chapters are longer from chapter 7 actually onwards, and we are in number 8. In fact, the Blitter has got 2 chapters, and that I believe is about 60 pages just on Blitter. So you can imagine that we're going to spend lots of time discussing Blitter. So how do we make equalizers on the Amiga? And I'm going to jump back to the Amiga, and I'm going to show you what we're going to discuss. Okay, so I hope you can hear me properly, but notice there are 4 bars. Each bar is playing depending, is moving up and down depending on which channel is being played. Okay, remember it is channel based first of all, okay, not instrument based. So this is when a channel fires up, then we have a bar. When it's not playing anymore, it starts decreasing. So that's what it's doing. Notice also that each bar, okay, these are copper bars basically, is composed of 3 lines. Okay, you have a color and a black, which is shadow. Okay, so we will see how he did these also. So this is the technical book. Okay, as you can see, there are no comments in relation to the source, just a question how they are done. We go and see it in the big book. Okay, lesson 8i, which is the examples. So okay, I know it's in Italian. Sorry guys, I'm taking off the jacket. But you don't need, I mean, remember, assembly is assembly no matter what language you speak. Okay, so as long as you have me to explain it, you should be able to understand the source. 68,000 is 68,000. It's not going to change. It's standard for everyone. So just because the book is in Italian, it's not an excuse not to understand the assembly. Of course, for those that are new, the parts that I do not highlight is because I have covered them in the in previous sections of my videos. Okay, but so for example, I'm not going to discuss the startup file. We have discussed it already 1 million times, the startup file and what it has. So this is what we're going to cover. So as you can see, the branch to subroutine empty init is to initialize the music. Okay, the branch to subroutine empty music is what plays the music every frame. Okay, and here, okay, I did not highlight it because we have covered this, but it is here. That's wait for line, raster line 130. Okay, so somewhere at the bottom of the screen. Okay, as you can see, this is 130 here. Remember, Fabio optimized this routine to check for a raster line so that it is more fast. So it looks strange with the 2 dots at the back, but it doesn't matter. They are ignored. It was, I believe I covered this in episode number 29, for those that want to know. Okay, so here, where I have pink or violet, depending how you see it, it's we play the music. Here, this move byte, okay, #2 equals speed, is to say by how much the equalizer goes down, basically, because when the channel fires, it goes up immediately and then it dies till it reaches 0, or actually position in the X7, which is the beginning of the screen in the copper, when you have a copper raster line or copper bar just of 1 line. The branch to subroutine is the routine that does the updates to the equalizers, and here we have the empty end. So before you exit your program, you need to call empty end to stop playing the music. So I'm going to explain what is written there by going on the code. Okay, so don't be alarmed. So first of all, the Amiga has 4 channels, right? So we need, let's say, 4 routines, one for each channel, to update the equalizer. So we have 4 bars. So if you notice, this part is the same like this part below, okay? Where you could see my mouse pointing, and it continues like this, okay? So there is channel 3, channel 4 basically, but they are the same. So if I explain one channel, which is here, it's the same for the others. Before I do that, you need to see the copper list, and this is where the bars are being drawn on the screen. So basically we wait for 1B07, okay, and we change the color to violet or pink. I mean, for me it looks more pink than violet, but he calls it violet for some reason, okay? And then when we finish drawing that, depending on where it needs to stop, we change to blue, okay? You can see here we're changing to blue, and then we do the second line. For, you remember, each bar is composed of 2, actually 3, one of them is black. So, and we do the same thing for the second line, and then we change to blue. We draw black, so you can see we have black here, and then we change to blue because the background was blue, okay? So that's our copper list. You should all understand this now by now. So now let's explain what is happening on the equalizers. So first of all, he does a check, okay? He loads the speed, okay? But he does a check where we are in drawing the copper bar, okay? Or the equalizer bar. I should call it equalizer bar, not copper bar, because I might confuse you. If it is a 7, then we have reached the bottom of the screen, you know, the left side of the screen. So we should not continue to decrement. So we should not decrement. You see here, we are subtracting, okay? The 0 contains the speed by how much we are subtracting. So we are subtracting by 2 basically here, okay? If we are, if on the other hand, okay, the how to say, the play routine has got a variable in it, okay, or a memory location, depending how you want to see it. I prefer memory location than variable, but some people call it variable. Has got a memory location where you can check if a channel is playing or not, okay? So here, if a channel is playing, okay, we immediately, okay, go to the maximum, so A7, and that is, you see where it is saying wait EQ1, EQ1B, EQ1C, that is, and just to remind you, to show you, that is in our copper list, okay? Here I'm indicating for channel number 2 instead of channel number 1, although we are doing channel number 1. And the reason why I highlighted channel number 2 instead of channel number 1 is because they are all together on the same page. While here, if you can see, you see wait EQ1C, wait EQ1B, and wait EQ1. So that's how he's updating the copper, by going to the maximum of how much the bar can be, you know, long, and then we just decrement, okay? So if the channel is not playing, okay, we pass to channel number 2, okay? And you can see, we check if channel number 2 is, you know, at the bottom, and it continues and continues like that. So that is basically the routine. Oh, thanks for the follow, Vamp. I'm honored actually that you're following me, so really thank you. So this is basically the routine that to show us how to play music and to create equalizers. Okay, now at the end of this exercise, okay, or lesson, okay, you see here there are 4 modes. Okay, here he says try to change the music. Okay, but because I know what's coming, I'm not going to do it here. In the next lesson, okay, we are going to be rotating through these 4 mods and playing them all 4 together. So we don't need to waste time playing one and then the other. Hi, Flypy44. Thanks for the follow. I do not need to do this part of this exercise because, as you can see, exercise number 2, we're going to do that. I'm going to jump for a second to the book, the technical book, okay? Because 2i, there is something that he's saying and I highlighted it in red, just making sure that I say it. Okay, what he's saying, I said it, that he updated the routine, and so not to compare it to what we did in example number 6, sorry, in chapter number 6. I believe it was the last example of chapter number 6, where we had a small demo of of a scroll and text being printed on it and playing music. So yeah, the routine is different, but it's always the normal, let's say. It evolved, it grew, you know, it updated itself, the routine during time. So Fabio updated it. It just said not to compare it. Okay, so now we are going to do lesson 8i2. So we jump back to the examples book. And remember, this is the book that has got 1,872 pages, and the technical book has got 400 pages. For those that are new to this, I'm using both books, okay? So I'm jumping between one book and the other because Fabio covers theory on one book and then he gives the exercises on another. However, some of the exercises, okay, or lessons, has got documentation within them, which he did not include in the technical book. So when if for all those that bought the book, okay, the physical book, the physical book doesn't contain all the technical documentation, okay? So that's another thing why you need to have both. It's impossible to print the 1,872 book, just to make you aware. No printer will print that for you, but you can maybe divide it. I mean, up to you if you want to print it. I'm happy with the PDF so far. So let me show you, let's jump to the Amiga and let me show you, okay, the next example. As you can see, the include bins are showing the mods that I just explained earlier, that they are loaded here, so no need. Before I run this example, I'm going to play them and by pressing the right mouse button, I believe, I hope I'm not going to make a mistake as I will exit. By pressing the right mouse button, I will be changing from one music to another. And then I will explain how that works. So as you can see, the examples always grow from one to the other. So the first one is how to play one module, and now we are going to rotate. So he added another step. It's always like this, the book. So as you can hear, we have the same music that we had before. What I forgot to mention is the bars at the top. We are playing, so basically the bars at the top are changing depending on the channel. So I will be also explaining how to change the color based on, no, sorry, not on the channel, based on the instrument. So I will be covering that also. So if I press the right mouse button, I should be changing the music. Oops. So actually, as I said, it is left mouse button, not right. For some reason I had the impression it was right. So I'm going to change the music now. So this is the second one, third one, and fourth one. And now, of course, we're going to start again from the beginning where we were. Okay, so we rotated, and it continues like this, rotating. And as I said before, top part is where we play, where the colors are updating depending on the instrument. So let's go through the source. Okay, so we are on the examples book, and I'm not going to cover, okay, so as you can see, there is the code that I have already explained, but we have the routine that we had before to update the equalizers, okay, and now we have a routine which I'll explain in a minute. But before that, okay, I'm going to show where we are loading the music, okay. Okay, so here we are loading the 4 modules, okay, using include bin, okay, include binary file. So, and each file has got a label, okay. Each module has got a label. So now, okay, what he did, I'm just going to go up again. And this is where I wanted to be. So we have, he created a table with pointers to our 4 modules, okay? Now what he does, and this we have seen, this routine we have seen it several times, but not used with music, but it's the same thing. We were doing the same thing, rotating from sprites, for example, or copper bars. We were cycling copper bars using the same method, okay. So basically we are cycling through each one of these through this part of with this code basically that you see here. So as you can see that we are actually, you know, updating the pointers, okay, moving them. So what's at the bottom, I think, becomes at the top. So this moves here, this moves here. I believe, if I remember, I do apologize if I make some mistake. As I said, I don't know if you, in the beginning, I said I have been streaming for 5 weeks, okay. I had a hard disk crash before, so I even had problems there. But every time I stream, I always have 2 lessons. I'm always 2 lessons ahead. So in total, it's been nearly 2 months. It's been since 2 months since I've done the notes for this one. So if I make a mistake, I do apologize because it's not so fresh in my memory right now. the other thing that I want to say is the how to say it, the code. Okay, Fabio's using, for those that has joined today or haven't been on the streams before, Fabio's using a technique when I mean, in book writing now, I'm talking, not a technique related to the Amiga, of always adding a small little thing. So to explain something, he will have like 10 examples, okay? And we go through each example, and each example adds something to it, okay? I have also, and I'm going to stop a little bit from the book and jump to, because I forgot to mention it in the beginning, okay? I have also done a page, okay, which is this page that you are seeing on the screen. If you type in the chat !book page, I have a page with all links related to the book. If you type !book page, okay, you should have a page. You get a link, because it's impossible to show on the screen because it's a link. It's a long one, where you get links related to the book. So, and I'm constantly updating this page. I mean, all things that I went through when I was going through the book, I was adding them here. So I'll jump back to the book. So the routine where we have equalizers, equalizzatori, okay, is the same routine that we had before. But he added, okay, the color changes at the top. And you can see, let me find the copy list. There they are. This is, I haven't highlighted them, so that's my mistake. But these are the colors that are changing at the top of the screen. I just want to correct myself. It is also with the channel. They are changing with the channel, not with the instrument. So if you had to, okay, ignore the parts where I highlighted in violet or pink, depends how you see it. He calls it violet. I see it as pink, but anyway. It is the same routine. You can see here the A7 when it jumps back to the full bar. It's the same routine that we had before, and it is this code is repeated in all the channels. So that's how we are changing the top of the screen by doing this colors, updating the colors in the copper list at the top of the screen. The rest is still the same. This part, I highlighted it yellow just to remind me, but normally I make a difference when I use two colors like this. Normally this is the important part, and this is just to remind me. This is the same as we had before, okay? So it didn't change. As you can see, it's waiting for whether the line is at the bottom, I mean on the left side, sorry, of the screen, and then if not, we subtract 2, which is the equalizer speed, which is in the 0. Okay? As far as I know, there is nothing else that I should cover in this in this example. Okay, so let's jump back to the technical book. I want to see what's next. Okay, so we are going to first of all, you see on the left-hand side of the screen in blue plotting. That is because this chapter is the only chapter that doesn't have sections. Normally the book is, each chapter is divided in sections, but for some reason this chapter was not divided into sections. So I divided it into sections, and here we're going to see routines, how to plot, let's say, pixels to the screen. There is one example which you can see here, 3D stars.s. I think this is my fault. I do not have the source of this one, but because I modified, I didn't keep the sequence, not the sequence, the layout of how he organized them on the disks, because I added my own stuff to it. I could not find the 3D stars, but if you download the disks, it should be there. The 3D stars is not covered in the exercises book, but it would have been nice to just see it, run it, and see what plotting can do. It is not normally the way stars are created on the Amiga, when you see the moving stars, but he just showed an example just to get ideas. Okay, so some things that I show here, okay, it's not what's really done. Okay, it's just he's explaining things. So if I'm showing plotting, because I said this yesterday, because there was somebody that was very good in 3D graphics on the Amiga, and today I believe we have Proton, so there we go. I'm explaining what the book is explaining, okay? I know there are other methods or other ways or improvements or how to improve it, but I do not want to go there. As I go along, the code will improve. This is how he does. If you notice, for plotting, I have from 8L, okay, till 8N3, okay? So that is all plotting. So we are going to explain all those. So let's start with the number 1. Actually, I should show you on the Amiga first. So we just have a dot on the screen. Okay, that is all. We just have 1 pixel. The thing is how we can plot a pixel to the screen. I'm noticing. Sorry guys, give me a second. Okay, I was not seeing the Amiga properly. Okay, so let's jump to the code. So 8L is how to plot a dot to the screen. Before I jump to that, actually, let me start, and then I can jump to my slide or whiteboard. So what we have here is we have a routine that plots a pixel on the screen, okay, which is this one, the BSR plot pix. But we tell it where to plot it, okay, with the X and Y. So we are passing 160 in the 0 and 100 in the 1. And this is the plot routine and what it needs. It needs 80, okay, to have the address of the bit plane. We only have one bit plane, okay?
Hey, listen!
Oh, sorry guys, I forgot to switch to the book. Okay, so let me start again. So the routine, okay, just plots, that's what he's saying here, plots a pixel to the screen, okay? The routine, our code jumps to a routine called plot pic, okay, or pix, and we are passing the X and Y of the coordinate system on the screen to plot or to switch on our pixel on the screen. Let's put it this way. We are going to jump to the plot routine. Okay, so first of all, the plot routine takes 3 parameters. 80 is the address of the bit plane, and we only have one bit plane. So we can only have a color and black. Let's say that. Or whatever, what is our background. In our case is blue or cyan with black. And then it takes the 0 for the X and the 1 for the Y. And notice they are word. Okay, so I know what you're going to tell me, okay? Or some people might have noticed, okay, that the Y is only from 0 to 255. This can be bigger if we want, but normally it is 256. Normally we have a screen which is 320 by 256, okay? So this routine can only handle that size of screen for now. Okay, so the first line, okay, we are saying how many bytes we have on our screen. This screen is 320 division by 8, we have 40 bytes, okay? So that's what it means there. Then we move the 0, okay? It is our X, okay? And we store it in the 2. And you will see why. We are taking a copy of it, okay? Then we logical shift right. We divide what we have in the X, okay, we shift it to the right by 3. That means we division by 8. So basically we are getting, okay, the columns, okay, or bytes that we have to move, okay, from left to right, okay? That's what it's doing there. Then we multiply the Y with our with the number of bytes that each line has, okay? So if we are on line 2, let's say that to make it simple for me to calculate, we do 40 times 1, right? Because line 2 is, we start from 0. 40 times 1, and it is 40. Then we add the 40 plus whatever we have in the 0, okay? So D1, as you can see, it's D1 and D0, and we have where we want the byte, let's say that, where we need to switch on a pixel. From that, we take, so we have a result in the, we have a result in, how to say, in D0, okay, that of the addition, but we stop here for now. Just keep that number, okay? Now we are going to take D2. Remember, we stored what was in the X into D2. Hi Bjorn, thanks for the follow. From that, we, so sorry, because I lost track. We have a copy of X in D2, okay? So we take, remember, we need just where in a byte we're going to switch on the pixel, you know, and we have eight possibilities in a byte, no? So we end the last 3 bits of X, okay? So we take the last 3 bits of X. We use the not to invert, okay? And then we set, okay? We set, be set, okay? We are setting the pixel on by putting the value that we have in the 2, okay, into the in the 2 with a 0, remember, has got the bit plane address, and the 0 has got in which byte, okay, we have to write, okay? So a 0 has got the base address plus where we are on the screen, the byte that we are on the screen, and then we set the bit in relation to where we need to switch on basically the pixel. And that's basically it. As you can see, there's an RTS to our routine, which I didn't highlight. Now, this is how it is done in code. I'm going to switch to my whiteboard, given that I see it also, because you're seeing it and I'm not. I just wanted to, I hope you can see it. I'm not sure. Can you read it? Because I did this exactly before the stream, but maybe I can zoom a little bit. This is our screen, okay? And we want to plot a dot here somewhere on the screen. So I took the example of once X is 165. So what we do is we divide X by 8 and we get 20 bytes in this case, okay? So we are at, let's say 160, okay? I mean, this is to indicate that we have 1 byte here, okay? Sorry, I forgot to, I mean, where I have the gray lines, I put blue with green in the middle. This is where we want to write, and to indicate this is 1 byte, but actually we have this this part where the red dot is where we want to write. So we have 160, so we arrived somewhere here, okay? Then we add, okay, the remainder is 5, okay? So we know we need to set bit 5 for our pixel. This is what the code is doing. I hope I explained this. This is my way of interpreting it. It's not how you know, he didn't mention this, so this is my addition, and I hope it sinks better in your head. Yesterday I didn't have this. When I was doing the Italian version, I didn't have this, and I felt that people were looking at me saying, what have you just said? So I did this quickly. Hopefully it will sing better. So we jump back to the book. And I need to go back to the book. Just because you see the book, it doesn't mean I'm seeing the book. I need to switch scenes. I believe that is all that I need to say for this lesson. Yeah. So that's our first, let's say, code for plotting a pixel to the screen. Now, let's jump to the next example. So I'm going to go to the Amiga. I'm going to execute it. And now the same routine, the plot routine, we are plotting a line to the screen. Remember, we always have one bit plane. Okay, so let me jump to the book. And what do we have here? How we are plotting that line? So, first of all, I'm just going to highlight this. Okay, so from school, back when we were at school, y equals m times x, or m times x equals y. Okay, or in Amiga terms, coefficient, whatever that is, a number, times the 0 equals the 1. Okay, so you know that the 1 is y, x is the 0, and coefficient is whatever we decided to be. In this case, because we're plotting a straight line diagonal at 45 degrees, let's put it this way, we are multiplying x basically with x. So this part of the code is what it's doing. So as you can see, we are incrementing x by 1. We are moving, μx is where he's storing it, okay? We are moving what we stored in μx into the 1. We are multiplying whatever is in the 1 with the coefficient, which happens to be the same, okay? We compare if we reach the bottom of the screen. The 255 is when y is at the bottom of the screen, okay? If we stop plotting. If not, we plot. We pass the x, okay, from μx, which is my x, okay, that's what it means, μx, and we called the plot pick routine, which is the same routine that we had before. Here I'm highlighting it, but this is to wait for raster line 130. So every time we hit raster line 130, we plot 1 pixel basically. That's what's happening here. There is this is the routine, the same routine that I just covered earlier in the previous example, okay? And I just highlighted it to show you that nothing changed. It's still the address of the bit plane, and the 0 and the 1 points to the X and Y. And nothing else. If there's anything, I would have highlighted it. Here is, so just, I didn't highlight it, but it's common sense. I'm just saying, because maybe you see lots of text and you say what he's saying there. He's just saying what's happening when you do 1 times 1, 2 times 2, etc., etc. You can see it. He's going to plot it here. Okay, and this is what's happening to how we get the line at this angle. Okay, so we have finished that, and we jump to the next routine, 8M2. So let's jump to the Amiga. As you can see by the examples, we are, on each example, we are adding something each time. Oh, sorry. Yeah, I thought I ran the same example, but then I realized it's not. So we are using a formula, which I'll come to, which gives us this basically. Okay, so before we were multiplying everything. So if x was 1, we multiply it times 1. If x is 2, we multiply it times 2, and it continues like that, and it produces that. Now we are not doing that. Okay, also we don't plot one line, so that means that our routine, okay, is in a loop. Before, sorry, not our plot routine that was plotting a line is in another loop. Okay, before we had just one routine that called the plot pixel, okay, and it just plotted a line. Now we're plotting more than one line, so even that is in a loop. So let's jump to the book. Again, what you see in red is to wait for line 130 on the screen. Okay. I highlighted it because there are 2 of them, one before we start and one during. Each time we are plotting, before we only had one. Okay, but notice what we have, the pink line, the branch to subroutine calcola la linea, okay, which means calculate line. Then we have the we read the coordinates, okay, from my x and my y, okay, and we go and plot the pixel, okay, and we loop. So if you where is, so mouse, so you can see if the mouse is not pressed, we loop back to up here. Okay, so we have a routine for plotting the pixel, and we have a routine for plotting, I mean, a way of plotting the lines. Now, this is the routine that plots the line, the odd lines. Okay, and now we are introduced to some variables or memory allocations where we are storing the coefficient, okay, I mean, before we also had them, but they were not important at that time because we had just read them once. Now we are storing that multiple times. So they become important. Also, you will see that the coefficient is changing. Before, when we plotted the line, it wasn't. It was always the same value, or a copy of x, basically. So this is what we are doing. We are using the same formula, okay? Y equals m times x, or m times x equals y, or coefficient times the 0 equals the 1. This time, the coefficient is changing, okay? So that's why we see those type of lines more, you know, like going to the left, and we get that pattern. Okay, so here, okay, we have the same thing as before, increment x, okay, then move x to the 1, then multiply x with the into the 1. We compare, always this compare if we reached the bottom of the screen, okay, so we don't continue. If not, we are, once we finish plotting, we are, so we, once we reach the bottom of the screen, okay, we need to start another line. So here we add 1, okay, we compare that we haven't reached 8. In fact, we have 1, 2, 3, 4, 5, 6, 7, 8. So this 8 here, okay, is to draw 8 lines. So we are incrementing that, and which is the coefficient. Once we've done that, we have finished drawing the 8 lines. But each time the coefficient is changing, okay? So that is why. So when we do the multiplication here, okay, it's different because we are incrementing it also, not just doing it like as before, x times x. Okay, so if before it was 5 and we did 5 times 5, now it becomes 6 times 5, and hence the line moves towards the left, let's say. I don't know how to explain it, but I hope you get the gist. That is all. So basically, that's the only addition that we have to our routine, to our code. So it's the same code as before by adding that. And as you can see, the plot routine is still the same. And we move to 8M3. So let me move you to the Amiga to show you what we are going to do now. So we are going to plot some dots which take a different pattern, let's say. Always using formulas that we should know through maths, which I have to admit, I completely had forgotten about them. But anyway. But yeah, it had to be this book to remind me of them. So let's go back to the book. We are going to do exercise 8M3. So what changed? This is what actually changed. We have another routine, calcola potenza, okay? How to translate it? Calculate power. Is it correct, Ozzy? And then whatever the calculation produces, we read my x and my y, and we plot the dot. Again, we have the weight for line 130 on the raster line, raster line 130, and we have it again at the bottom because we are plotting, we are waiting, and then we jump back to the top. So basically, because we are waiting twice to line 130 in this case, I'm not sure if it was doing it also in the previous example. So I do apologize if it was doing it also in the previous example. I didn't mention it. That means the dots are being drawn not every frame, but every 2 frames. So, calcola potenza. This is our routine, okay? As you can see, it is x times x, okay? And in this case, it's the 0 times the 0. Practically is the same as we had before, okay? Just a different way of calculating the line. I mean, a different formula, but it's the same code. Just here we are, if I manage to highlight it, because we didn't have this before, we are doing a logical shift right. So D1, okay, is being divided by 8, basically. Since we are doing a logical shift right of 3 positions. But the rest remains the same. We're still adding 1 to the coefficient. The comparative is, oh, okay, so instead of here, oh, sorry, here is when we check for the bottom of the line. And he's also checking if we've done abbiamo già fatto 39 linee. I honestly forgot why he's doing this, but he's checking for if we've done 39 lines. I'm not sure what he means by that. It cannot come to my head, so I do apologize. But the routine should be the same. I cannot, because I'm on a stream, I cannot really get them next to each other, but they should be the same with this modification. That's the only modification, the logical shift right. The plot routine is still the same. Why I'm mentioning the plot routine is still the same? Because it's going to change. So right now we're still using the same plot routine. There is something that Fabio doesn't like, and it was also pointed to me yesterday by Ozzy, I believe, that this is slow, okay? So the multiplication is a slow thing on the 68,000. So we're going to change that eventually. So I'm giving you heads up. Also notice that we are only plotting a single color on 1-bit plane. So we are as far as I know, we've done Then it all here he's explaining what's happening like before, okay? So 1 times 1, 2 times 2, 3 times, and how they are calculated. We are going to do lesson 8 M4. So let's jump to the Amiga. Yesterday, as discussed with Ozzy, okay, he should invert the x and the y. He's not doing that here, okay? So that's why you see gaps between the dots. It's not the point of that. So that's why in the beginning, when I started doing this, I pointed it out for those that are good in doing 3D, that the dots, this routine is not how actually things are really done in if you are doing something in 3D. Okay, so I believe that finished. I thought it's going to draw another arc, but it didn't. So let's jump to the book. And as you can see, this is the formula that he's using. Y equals A times X times X. Okay, so with that formula, which we should have done it also in school, you get that pattern. And varying, I believe he's varying A, you get that pattern, the second one, so you can continue. He does it twice. So I have highlighted again the weight for raster line 130. That because, as I said before, it's being drawn every 2 frames, not every frame. The plot is happening every 2 frames. Now notice another thing. We don't have plot pixel. That means plot pixel is in our calculation routine. Okay, so before we had the calculation separate. Now we have the calculation and the plot together. But to be honest, not much changes except for this. The formula, as discussed earlier, is y equals a times x, or coefficient times the 0 equals the 1. So we're going to vary the coefficient. I believe there are 2 multiplications, as I could assume. One is these 2, and then with the coefficient, of course. And again, we do a logical shift right, and this time we divide by 256 because it's a hash 8. Okay, and we check, I believe, bottom of screen. So this check is for the y if we reach the bottom of the screen, and this check here if we have reached the right and top, I believe. Top, I think. No, to the right, sorry. But apart from that, it's the same. As you can see here, we're adding 1 to the coefficient, we're comparing 3. So have we done the loop 2 times? And if so, we exit, I believe. Yeah. He is also changing, you know, when the how to explain this, the minus 160 is when x changes from 1, you know, it goes to the top and then is going down. I believe that's what it means there. Yeah, so here is the minus 160, here is the addition of 160. So yeah, and as I told you, the plot pixel, okay, is inside our calculation routine. Before it wasn't. Yeah, minus 60 to center the parabola. The plot routine is still the same. As I said, guys, I do apologize. I'm taking my time because I've done the notes seriously 2 months ago, and my mind was not on the book, but was on the house move, to be honest. So, yeah, I have forgotten some things. I believe there's nothing more to discuss in terms of this routine. Yeah, this is what I was referring to. So first we add 160, then the 160 becomes minus 160 to plot the other part of the curve. And that's basically it. So I believe, and let me check before I do this one, I need to check if this is where it's still using the multiplication. Okay, sorry. I just wanted to make sure that I don't give you the wrong information. Okay, so 8M5. And I need to switch you to the Amiga. So it's doing the same as before, but in a loop and the opposite way. I believe before we had 160. Let me see before I tell you. Okay, it's still plotting. Okay. So basically, before we were calling or doing the loop 2 times. Now we're doing several times, and we are also inverting, or how to say, what we plot before. We only saw 2 that goes to the top of the screen. We are seeing also we go to the bottom of the screen now. So that's the difference, and that's the addition to our routine. Let's jump to the book. So let me go up. So the formula is still the same, a times x times x. We are still plotting every 2 frames with the same formula, as you can see. Still same formula, but we are looping more, and that's why we get the top and the bottom curves, let's put it this way. I'm trying to see. You see now, this is the difference between this one and the other one. I will go to the other one. So here we start with minus 160 and with minus 5. But so we are inverted in a way. You want to think about it like that. I mean, I'm thinking the opposite way now. If I go and check the other code, we should not have minus 160. Oh, we do. So what changes the coefficient? Sorry. That's how, and we are looping it more than once, more than twice. Before we were looping twice. That's what changed. Yeah. So we are varying the coefficient again. But so from this, what you see on the screen, and you can compare it to what you see on the on the right hand side at the bottom, the Amiga, you can see that 2 of them are the same. I mean, the same 2 that we have there, and then we added more. So because we made the loop go longer, basically. But same formula. The coefficient you can see is minus 5. And that's why we get this effect. I think how many times we are looping. So here he's comparing that the coefficient is 6, Yamoja coefficient 6. When we reach 6, jump to 1, he's saying. So that's why we are looping. Let me see if in the notes there's something. There isn't anything else in the notes. Okay, this explains it. In this listing, he's saying the only modification we did is that we use a coefficient with minus. So before we had -1, but we have more, okay? More negatives. That's why we able to see this. As I said, I do apologize, guys. It's been 2 months, and somehow I'm forgetting certain things. It's one thing, you know, when you read the book yourself, it's one thing, but then when you come to teach it, you need to know more, no? And if you haven't done the lesson, as I said, normally I'm only 2 weeks ahead normally, and I keep one as backup just in case something happens and I didn't manage to prepare. So that's why 2 weeks ahead. It's incredible how you forget when you want to teach it. So as I said, I do apologize. I did not like the fact that I had to stop streaming for 5 weeks. I really did not like it because I knew this was going to happen to me. Okay, so we're going to do 8n. Okay, so maybe let me check the plot routine just to make sure. Okay, so this is where we remove the multiplication. Okay, so let's jump to the Amiga and show you what it does. It's the same routine that you've been seeing when we started. Okay, it just plots a pixel to the screen. So you say, hey, what changed? What is the what changed here? Basically, he has optimized the plot routine, sorry, and it doesn't use the multiplication anymore. Okay, because using multiplication in 68,000 is slow. So let's jump to the book. And this is the first thing, how he is plotting things to the screen. Basically, he's using a table. He creates a table of where we need to plot. And because of that, okay, it's very easy to plot to the screen. What he does is he takes 256 bytes, 256, sorry, words, okay, and he creates a table of 256 words where each line on the screen starts, and then he just adds he just adds the X to it. So if we are on line 2 or 1, because we start from 0, we know that line 1 starts at 40, okay, at 40 bytes. So this is what I highlighted here. This is what it's doing. It's creating a table of 256 words, okay, with the address of each line in our bit plane. So when we plot, okay, so here is our plot routine. Okay, we still pass the X and Y, okay, and as you can see, he's taking the Y and read the address where we are on in the table. It gets the address from the table, and then the routine was modified, the plot routine was modified, that it takes an address of the bit plane. Okay, you always need that. the address of the table where we have pre-calculated addresses, and then as usual the X and Y. And as you can see here, the multiplication is remarked. Okay, so we are not doing that. Instead, we have got that from the table, which is this one. Okay, and all we need to do is add the last bit, which bit needs to be turned on, and add the X. So this is adding the X of where we need to be. Okay, and this is adding the Y. So basically multiplying, we get the offset of where we are on the table. The rest is history. So now we know that we can use a table. Here is how he defined a table. Okay, define storage of 256, and it is Word. And he used the section, pre-calc, and the BSS. So basically, when the file loads, then the Amiga knows it needs to allocate 256 words in memory for the mal table for this. That is all. We do N2. So we jump to the Amiga. Today, not much theory, I have to say. We are only doing exercises. Well, the theory, we did it in the past weeks, no? So this one, yesterday I was not able to show it because I had a different configuration. I mean, when I started the stream, I realized that I had started the wrong configuration of the Amiga emulator that I normally use for streaming. So it didn't run. Excuse me. This example didn't run. Basically, for development, be quick, I enable JIT, and JIT is the issue here. Also, I was using the 68040. It's just, when you are testing and running, and then you know that you need to calm down and lower your speed if you want to really run it on a real hardware. And that's normally I start the emulator with the real in emulation mode for the real hardware, but yesterday I started my development one. So yeah, so basically what it does, we're filling the screen and then clearing the screen. And notice, so this is filling the screen 1 point at a time, 1 pixel at a time, okay? And then it's clearing the screen 1 pixel at a time. So you think it's scrolling, but it's not, okay? So it starts from top, starts plotting. When it reaches the lower right-hand corner of the screen, it starts erasing. So that's what it's doing. It's not that we have a blue screen scrolling down and then, but so, and this is to show that he's able to do it because he's using tables. So here again we have the routine that pre-calculates the addresses of the start of each line for each raster line for the bit plane. Okay, and here is our routine that is plotting the pixels, and then when we finish, we erase them. So let's jump to the book. So as I was saying, we have the routine that plots or calculates, okay, the addresses, okay, and then we have our routine that plots the pixels. Now, I highlighted lots of things here, but what's really happening is this. Okay, this is our plot routine, okay, as before. So what we are doing is plotting pixels one next to the other to the screen, and then we are erasing. So you think there's something wrong with the screen, but actually it's not. It's intentional what's happening. So what you need to know from all this, and unfortunately it's not letting me highlight what I need, there are two routines that you need to note. Is this one, what we know is the plot pixel, and then the other one, where is it? Erase pixel. Okay, so we are plotting a pixel and then we are erasing a pixel. The rest is in a loop to print one pixel next to each other. We pass it to the plot routine, and once we plot it, we go to the next. In fact, he's saying it here. We're passing the x and y from our routine. You know, we are incrementing x, we are incrementing y. So once we incrementing x from 0 to 320 or 319, then we increment y by 1, then we do again x from 0 to 319, then we increment y again, and it continues like that. So that's our loop. It's a for next loop. One is for the x and one is for the y. That's what he's doing there. That's basically it. I want to see if there's anything related to my notes that I should mention. So he introduced the routine that will cancel or delete a pixel, okay, which is the opposite of what we have. So let me find, okay, here is our routine that plots, okay, and here is our routine that erases, okay, and the difference between the plot and instead of having b set, okay, the instruction b set, we have where is it, b clear, bit clear, okay, so we're setting it off. That's what he's doing. So that's the only, so we have a routine, let's say duplicated, but one we use bit set and the other one bit clear. We have also, I realized, so here we have two routines, not one. So let me see that I am right before I erase. How many times we see it? Erase pixel here and erase pixel. Okay, yes. So I should have done this part. Okay, I'm noticing I have a mistake in my notes. So this should have been a different color. Why? Because this part, okay, the one that you see not highlighted, is using the old routine, not the optimized routine, not using the table, not using the table routine. And this part is using the optimized routine using the table. I don't think I said this yesterday, so my mistake. Actually, we didn't do this one yesterday, so I didn't say it for sure. But that's the difference. If you notice, the routines are the same. You can see here from the bit test to OK plottato should be the same. So erase. Here we go to loop for mouse, but here we go to down here, check for mouse. So, but it's the same routine. So we have the old routine with the multiplication, and we have the new routine with the table. That's the one with the table. So here you can see we're passing 4 parameters, and in this one we're passing 3 parameters. So he's using the 2 routines also. So one is fast, one is slow, one is fast, one is slow. To be honest, I cannot really see the difference, but I am running a 68030, so probably on the A500 that will show up. So that's basically it. And we do the 8 and 3 now. So let's go to the Amiga again. We exit this madness of drawing. And now we see a pixel moving across the screen and jumping. Now, for those that attended chapter number 7, okay, the table that we are using for moving the pixel across the screen is the same table that we used for moving the sprite across the screen. Okay, so we are just reading the values of the x and y from a table this time instead of doing a pre-calculation. And so we have table for the x and the y, and we are plotting the pixel according to this table, and we are getting this pattern. Remember, we generated this this pattern using either the is command or cs command in ASM Pro. If I press, I believe, the left mouse button, it doesn't erase, it continues to draw the pixels without erasing. And once I leave the mouse button, it starts erasing again, and you can see that the screen is erasing. So we jump to the book. And we explain the next example. I think it started earlier. Yeah, here. So this time we are using only the optimized routine. We are calculating the addresses of where to plot. Okay, but then we are reading the x and y from a table. So we read the x and y from the table. It's this line. We, well, actually, this routine reads the x and y from a table and stores them in my x and my y. We get them back and we pass them to our fast plotting routine or pixel routine, whatever. And if I press the right mouse button, it does an erase at the x and y. Okay, nothing else, and it is drawn again every 2 frames. Okay, so we have wait for raster line 130 and raster line 130 here. So that's basically it. As you can see, we are using the fast routine because we are passing the address of the table, of the pre-calculated table for the addresses of the screen, and we have the plot pixel and the erase pixel, but the fast version of them. This is the routine. We have seen this many times when we were doing sprites that reads the X and Y coordinates from a table. And somewhere down below, we have the tables. As you can see, this is the Y and this is the X table. And that's it. And we go to lesson 8 and 4. So let's jump to the Amiga. And now we are plotting to the screen with multiple color. Okay. We have a routine. Before we just had one bit plane. Now we have 3 bit planes. As you can see, we have 8 colors. Okay, 3 bit planes, 8 colors. Okay. This routine was not written by Fabio, but Fabio used it. I have to mention his name because he's a Phase 101 member, and at the time he wrote this routine and Fabio used it. So I'm going to explain how we are plotting that to the screen in color. So Lorenzo De Gaetano is a member of Phase 101. I'll jump to the book first of all. Lorenzo De Gaetano is a member of Phase 101, and he's the one that wrote this routine. You can see a routine. Okay, the routines are all the same, so I'm just going to mention them because I divided them. This is the routine that prints ciao. Okay, this is the routine that prints Amiga. This is the routine that prints live. This is the routine that prints the T of TAD. This is the A of TAD, prints the A of TAD, and this is the routine that prints the D of TAD. He has modified, so although he has 6 routines, what changes, and I'm going to show it. Where is the... That is waiting for the vertical blank. He's not using the... Actually, he is, but not on line 130, but 12C. I don't know what 12C is, to be honest. What raster line that is, but whatever that is, it's not 130. It's something lesser. So he modified the routine, the plot routine, okay, to take a bit plane, to take the X and Y and a color. Okay, depending on the color, we plot on a bit plane. So the plot routine has got this part added to it, which decides, okay, this part, which decides to which bit plane we are plotting depending on the pixel color. So in the routine, okay, he's using the tree for the bit to set, and the 2 is the number D2, okay, D2 is the number of the color. So that's how he's deciding where, on which bit plane to plot. This is the data for what you see ciao Amiga lives. Okay, and he is using the every raster, he is reading one byte each time, or two, I think two, more than one. Can't remember. Anyway, he's reading this data and plotting to the screen. Actually, this one is the X. Let's see. He's explaining the table here. The table is in the format XY. So 130, 106 is the first point, okay, that he's plotting. There isn't anything else. You can see here he's using 3-bit planes. So when he does the pointers, and these are the colors, and you can see them here, the colors, the names in Italian, but if you want to know, blue, everybody can understand. Red, rosso, everybody can understand, from wine, etc. So that is the routine to print colors. So I believe this is 8N. Let's go to the technical book. And we did lesson 8 and 4. So this is where I actually finished yesterday, and hence we are ending here also. Thank you for your follows. Today I think we were more than we normally are, so thank you all for your patience with me. As I said, I do apologize for I forgot some things, but I hope it was useful, it was beneficial to you all, and that you enjoyed the stream. Thank you very much, and see you in 2 weeks. Ciao guys, ciao.